Moving on. Can we move on now to the ellipse? Is that a yes? Is that a no? We have other questions. Do we have other questions? Anything?
I'm good to move on.
Okay, perfect. So let's discuss the ellipse. So this is our, again, the third conic section. So first of all, let's look at how the ellipse looks like. So this is one possibility. Here's another possibility. Here's a third one. The ellipses and the hyperbolas, they have center. The parabola has vertex. Okay, of course, these are centered at the origin. These are not. So the center is right here. The center is somewhere here, but these have the center at the origin. Perfect. Okay, so what are the major characteristics? So the ellipse has a major axis, and the major axis has vertices, V1, V2, major axis. It also has a minor axis. These are not considered vertices, of course, only these two. On the major axis, we also have, the ellipse has something called, again, focus 1 and focus 2, plural foci. Okay? What about here? The same thing. The foci are on the major axis, the vertices are on the major axis, and this is the minor axis. Same thing here. The major axis is vertical, like here, and it has vertices, and it has the foci on the major axis. Okay. So if you remember when we looked at the parabola, let's say this one has the focus right here and the directrix. We said that each and every point on the parabola is found at the same distance from the focus as well as from the directrix. Let's say this one, again, my graph is not perfect, but these two have to equal each other. What is the same idea here? Well, any point on the ellipse has a sum of the distances from the two foci, a constant. Okay, so here these two are the same. Here the sum, this distance plus this distance is the same, with this distance plus this distance. And the same with this distance plus this distance. Okay? So let me share my screen for a second, and let's go back to the next one. Okay. So the equation of the ellipse, it looks like this. Notice that it has to have 1 on the other side. And the options are either x squared over a squared plus y squared over b squared if this is the major axis, if it's, in other words, it's horizontal. But if it's vertical, this one is larger than this. So the equation will be slightly reversed. So let's write it. So we have a squared, x squared over a squared plus y squared over b squared equals 1, where a is greater than b. The other option is x squared over b squared. b squared plus y squared over a squared equals 1. So this is major axis is horizontal. Here, the major axis is vertical. However, notice the relationship between B, A, and C. And you can say, but you haven't talked about what is A and what is B and what is C. I will right this moment. So let me move on to the next page. And let's explain what A, B, and C are. And I think I am on page 5. Yes. Okay. Notice that I created the -4 and 4. So the two vertices, this is vertex 1, -4, comma 0. This is vertex 2, 4, comma 0. Notice that I used +2 and -2. So this is 0, 2, and this is 0, -2. Because half of the major axis is 4, A is 4. Because half of the minor axis is 2, in this case, in my simple example, B is 2. Now, the foci, so F1 and F2, they are both on the x-axis. So they have to have 0 for the y-coordinate. Well, this will be the -C and this will be the C. I'm just going to place them somewhere. We'll see if this is, I just made this up, right? So this is the F1 and this is the F2. Meaning this piece is C as well as this piece. So this is A, this is B, and this is C. Coordinates of the vertex or the two vertices and the two foci. So now, in order to determine the position of the foci, I have to write the relationship, and you see it here. All the formulas for you are given, right? So b squared equals a squared minus c squared. And you'll see what happens with this when we go to the last conic section, which is the hyperbola, okay? So, of course, a has to be bigger than c. It's obvious. Okay. So b squared equals a squared minus c squared. So in my example, if I want to determine the coordinates of the foci, all I have to do is just replace a, and I square it and put it here. So this is 4, b squared and put it here, and this is 16 and this is 4. Or just move terms around and you have c squared equals a squared minus b squared, depending on what you're trying to find. It doesn't matter. You can plug the numbers in and then find c, or just solve for c and then plug in the numbers. It's the same thing. So c squared will be, so a squared is 16 and b squared is 4. So then c squared equals 12. The square root of that, so c equals the square root of 12. What is the square root of 12? 3 point what? So this, oh, square root of 3.46, 3.5 approximately. So my foci should have been at 3.5 somewhere here. This was just a simple example to explain the characteristics of the ellipse. So I would write it, if you want exact or if you want approximate, I would prefer F1 as being -2 the square root of 3 comma 0, because that's what the square root of 12 is, 2 the square root of 3. And the other one, F2, the second foci, the second focus is 2 the square root of 3 comma 0. Any questions on this before we start looking at some problems? either horizontal or vertical axis. Major axis, I meant to say. Okay. Analyze this each equation, in which when we're asked to analyze, we are asked to find the center, vertices, and foci, and then graph it. So that's one option. And we have another option for, as you notice, these are reversed. Why? Because a squared is bigger than b squared, which means the axis will be on the vertical. I just got a warning that my other computer is running out of juice and I want it to record. So give me 1 second to make sure it's plugged in. It's plugged in. Okay, so which of these two you would like to start with? Either this situation or directly the ellipse with the major axis that is vertical. Any preferences? And then we look at some other situations. Any preferences, or I would choose?
You do both of them, please.
Yes,
Yeah,
absolutely. I was just waiting for you to say something. Thank you. So let's go back to this one. Perfect. So this is 22. X squared plus 9y squared equals 18. What do we need to do first? What do you think? Look at the equation. Let me write the equation again here. It's either x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. Regardless, what do we have to do first? For sure. Anyone would like to give it a shot? What are we trying to do? What is the first step? What was the first thing I said about the ellipse? Or the equation of the ellipse?
Would you divide both sides by 18?
Of course. We have, so that's the key. We cannot identify what we need before, thank you, before we get 1 on the right-hand side. Right or left, it doesn't matter, but we have to have 1 either on the left or on the right. Yes, indeed. We have to divide by 18. Perfect. Okay, so then the equation becomes x squared divided by 18 plus y squared divided by 2, because 9 over 18 is 1 over 2, equals 1. Which of these two is bigger? I know it's silly. So this will be a squared, and this will be b squared. Because we want to determine c squared will be a squared minus b squared. So 18 minus 2 is 6. So then c equals, I should write plus or minus, but it doesn't matter. Let's write it, doesn't matter. So 4. So eventually we'll have to graph the ellipse. So let's start with that. Now, because these numbers are, so in order to find a, which is the half of the major axis, I have to take the square root from 18, roughly. I need to see what it is. So the square root of 18, 4.24. Okay. 1, 2, 3, 4, 5, right here. 1, 2, 3, 4, 5, right here. So these are the vertices. So this one is 3 to the square root of 2. So negative 3 the square root of 2, comma 0. This one is 3 the square root of 2, comma 0. Now the foci, F1 and F2. C is plus or minus 4. So 4 right here, 4 right here. So negative 4 comma 0 and 4 comma 0. Oops, I already have the parenthesis. Good. Now we have the square root of 2, which is 1.4. Okay, somewhere here, somewhere here. And now I'm ready to graph the ellipse. Kind of skinny ellipse. Of course, centered at 0, 0. So we identify the foci, the vertices, the major axis, the minor axis, and these points, of course, they were 0 comma the square root of 2 and 0 comma negative the square root of 2. This point here and this point here. Any questions about this ellipse? Any questions about this ellipse?
Can you go over how you got the vertexes again?
Yes. So this is a squared, and this is b squared. So when we go to the general situation, so this is a negative a comma 0, and this is a comma 0. This is 0 comma b, and this is 0 comma negative b, and then this is c, and this is c for f1 and f2. So once I know that a squared is 18, I know that this is the square root of 18, and I know this is negative the square root of 18. Is that better?
Yeah, I see now. Thank you.
Perfect. And then from this equation, knowing a squared and knowing b squared, I replace them. I have 18 minus 2, which is 16, and then the square root of 16 will be 4. So then this piece here, this distance is 4 units, and this distance, in my example, and this distance is 4 units. So that's why the foci here, the left one, the first one is negative 4, 0, and the other one is 4, 0. Is this better?
Yes.
Perfect. Let's take a look and see what was the other one.
I have a question.
Yes? Ready?
How did you find the minor, what are these called?
The axis. So this is the
Yeah.
major axis, and this is the minor axis. So, yes. So this is a squared, and this is b squared. Once I take the square root of b, which is 2, I get this height, and then this height is the same, but under the x-axis. So this was the square root of 2, and this is negative the square root of 2.
Okay, thank you.
Thank you. They come from b squared. B squared is 2, which means this distance has to be positive the square root of 2, and this distance is negative the square root of 2.
So what would you call those points? Or is it
Nothing.
have a
These are the points that define the minor axis.
Okay.
These are the vertices,
Yeah.
and they define the major axis.
Okay.
I don't know any name that these two have any particular name that I know of. I know that these are the vertices. And the vertices and the foci will always be on the same axis, on the major axis. Other questions? Very good questions. Okay, let's go to the other one. This one. Okay. So here we have 24. 4y squared plus 9x squared equals 36. What is our first step? Anyone else then Blake can tell us what we need to do?
It looks like I have to divide by 36 again.
Alvin, I love you very much, but I want my students to answer my questions, please.
Oh, I'm sorry. I just want to keep it moving a little bit. Sorry.
Yes, you don't have to stay. Remember, this is only for your idea of how I present my class. My
Oh,
yeah.
absolutely. I was just going to
This
step
has
out.
nothing to do with the content for you.
Okay, fantastic. Thank you very much.
Thank you.
I'll
Have a good night.
Good night.
Bye bye. So what are we? Yes, yes, of course we have to divide by 36. So 4 divided by 36 is y squared over 9. 4 over 36 is 1 over 9. So then we get y squared over 9 plus 9 over 36. Well, that is over 4 equals 1. Do we understand this step?
Yes.
Perfect. Excellent. Good. Now you can say, but this is not arranged correctly. Yes, I would agree. This is not arranged correctly, but now it is. Now this is correct. Now, can anyone identify for us a squared and b squared? And then we will determine c squared in a minute. Can anyone identify a squared and then b squared?
A squared will be 4.
Always the larger of the two.
Okay.
Always the larger of the two. Okay. And b squared is
4.
4. And c squared is a squared minus b squared. And that will be 5. So then c equals the square root of 5, and the two foci in this case, f1 and f2, let's not rush. Let's put what we have, and then we'll decide. Because the bigger number is under y, the major axis is on the y-axis. So the square root of 9 is 3. 1, 2, 3, 1, 2, 3. This is 0, 3, one vertex. The other vertex is 0, negative 3. So when I determine the foci, they are on the same axis or the same line with the vertices. So therefore, they have to have the same x value. Now the y value is this. The one at the bottom is the f1, the one at the top is f2 in this case, or left and right, bottom up. So then this is negative the square root of 5 right here, 2 point something, and the square root of 5. What is the square root of 5? 2.2. So then 2.2, 2.2. So this is f1 and this is f2. What about b? Left and right, the square root of 4. 1, 2, 1, 2. This point, this point. This is negative 2, 0. This is 2, 0. And I have defined and analyzed the ellipse. So this is it. Yes, you can look. Again, I show this for you, but I'm not really happy with the fact that I cannot change or look at, zoom out or zoom in. So it's an ellipse. As you see, it has A, which is bigger, under the Y. It's, in our case, it's centered at the origin, so H and K will be 0. So I'm going to choose the second one. And A is 0. I'm sorry. A is 3. B is 2. And 0 and 0. And when I click graph, it's going to give us the graph. It's a better graph than the parabola, but I would have liked to be able to choose the window and zoom in or zoom out if I wanted to, but it doesn't allow us to.